Hello everyone! We're excited to share our latest work, SKIP, the Sparse Keyframe Interpolation Paradigm for efficient embodied world models. An embodied world model lets a robot imagine its future before acting, but generating every frame the way previous methods do is slow and wasteful. SKIP takes a different approach. It generates only a few event-preserving keyframes, and then reconstructs the dense rollout from the robot's actions, about 4.16 times faster. Those generated videos can even be used to train downstream policies. Our key insight is that a manipulation sequence is really just a few decisive events: approaching, contacting, grasping, releasing, joined by smooth, near-redundant motion. Those events carry most of the information, but we can't simply drop the frames between them, because losing the one where the gripper closes would break the whole rollout. SKIP works in 3 stages. First, the selector reads the dense trajectory and uses multimodal cues to pick the keyframes that matter. These then teach the generator to synthesize just those frames from the initial observation and the language instruction. And finally, an action-conditioned reconstructor fills in everything in between. At inference, only the last 2 stages need to run, and that is where the big speed-up comes from. And from just those keyframes, SKIP recovers the full, dense rollout. To see how well this works, we compared SKIP against the ground truth across long horizon, object, and goal tasks. SKIP stays faithful to the ground truth, even on long sequences, while the dense baseline gradually drifts and blurs. Which keyframes you select also matters. Generic selectors like RDP, Uniform, and TripSS each drop critical moments such as the grasp, and you can see it in their reconstructions. SKIP's robot-aware selection, on the other hand, preserves almost every key event. Generating only the keyframes also makes SKIP fast, about 4.16 times faster than dense generation. Side by side on the same hardware, the dense baseline takes about 157 seconds for a single rollout, generating 200 frames one at a time. SKIP finishes one in just 37.9 seconds and gets through 4 in that same window. Even better, the videos SKIP generates can stand in for real demonstrations. When we train policies purely on SKIP video, they come within just 1.3 points of policies trained on all real data, while dense trained policies collapse. And along the way, SKIP cuts FVD by 89%. This faithfulness holds on real hardware too. On a real Franca, SKIP rebuilds each rollout from just a few keyframes, and the result is almost indistinguishable from the real recording. Most importantly, these policies transfer to the real robot. On a real Franca, a policy trained entirely on SKIP video, with 0 real demonstrations, succeeds 67.5% of the time, nearly matching all real, and more than double what dense video achieves. In summary, for efficient embodied world models, sparse keyframes really are all you need. Thanks so much for watching.